Very good morning. This is Muthu Meenal, Assistant Professor from the Department of Agricultural Engineering, SMS College of Technology. Today, I have taken up a very interesting topic from the subject GIS and remote sensing. And today's topic deals with the concepts involved in remote sensing. The main motto of today's topic is only to cover the basic introduction involved in this concept, and why do we need this kind of remote sensing, and what is going to be the future impact of utilizing remote sensing in agricultural engineering. Uh, See, what is remote sensing and what may be it? Does anyone know? As I have showed you in this pictorial representation, remote sensing is nothing but the collection of data surrounded by us in order to make them abruptly available to everyone, so that it could reduce the manual work that is going to happen in the near future. Initially, at the previous video lecture series, I have also taken up some topics called surveying. And that topic itself, I have said that in order to collect the data that are involved in land, what we have to do, we have to collect the data specifically while going there manually, and we have to measure the distance, we have to point out the reference point, we have to mark reference stations manually, so that it will give us an appropriate data which will help us to create a documentation for the field work which we use an agriculturist. In order to do so, it consumes lot and more of manual labor, where we have to spend most of our time in measuring the distances. We have to have n number of people to store those kinds of data. We have to take ourselves in charge up to fill up the field books. So those kinds of problems could be avoided through the help of utilizing remote sensing. So that is why I have picked this interesting topic. So from this itself, I think that everyone would have guessed it. What is remote sensing, right? It is a kind of collection of data or acquiring the information about several objects without coming into physical contact with the object or the phenomena under certain investigation. This is what the remote sensing means. So it means, I have said that we are going to cover the data or acquire the data without any physical contact, right? But in order to sense the Earth's surface from space by making use of properties of ER rays is specifically dealt with in utilization of sensors under the consideration of satellites. So we do know that all the rays, electromagnetic radiation, is capable of traveling throughout the space, and these waves could be reflected or diffracted whenever it is hit or sensed by the object. For the purpose of improving the natural resource management, we are trying to utilize this kind of electromagnetic wave that has been reflected, diffracted, which could be observed or stored by the sensors available under the satellite, which is revolving at the orbits, so that the data surrounding that of the natural resource management could be collected, which could be implicated in protection of these kinds of environment. So without the direct contact, some means of transferring this kind of information through space must be utilized. In remote sensing information, transfer is accomplished by use of electromagnetic radiation. This is what I have shown in this pic also. As I have showed here, the electromagnetic radiation, for example, I have picked over the rays which has been collected with the help of sunlight. So the sunlight rays passes through the space, that is travel through the space, and gets incident on the vegetation. This vegetation, some of the rays will be observed and some of them will be reflected, so that it reaches the area. So this reflected rays will reach the sensor that is available in the satellite, so that that sensed electromagnetic radiation could be stored, operated, and converted into the data which is necessary by us with the help of the base station that is available at the ground surface. This is what happens under remote sensing. There are two kinds of remote sensing. One is active remote sensing and the other one is passive remote sensing. Active remote sensing is the one where the satellite is capable of creating its own sunlight, its own electromagnetic radiation. That is, it is capable of generating or emitting the electromagnetic radiation, and after emitting that electromagnetic radiation, when that rays passes through the surface and gets reflected, it will get sensed and observed by the same satellite. So this is what happens under active remote sensing. While the passive remote sensing is one where the electromagnetic radiation is created or dependent only over the sunlight. So the sun is the major natural source that is going to be available in order to create those kinds of electromagnetic radiation. This radiation will get incident at the earth's surface, then it will get reflected towards the space where the satellite will be available, and the sensor that is available in the satellite will observe it. This is the concept involved in active and passive remote sensing. So normally, if one comes across the term remote sensing, we always think of remote, that means far away, and sensing means observing or acquiring some information. Here I like to quote an example that whenever we are going to operate a television, what we'll do? We'll use a remote. For that, we'll operate with the help of the rays that is passed from the remote, and the channel will obviously change whenever we are pressing an option from the remote, right? This is what happens in remote sensing too. So the example which I like to show here is the sense of sight for watching cricket match from a stadium, and the sense smell freshly cooked curry, and sense of hearing from a telephone ring. These are some kinds of examples that involves in remote sensing. This is how the remote sensing has been elaborated. See, the remote sensing always integrates the concept that is geographic information system. Wherever we have a mobile app, we do have an app where we follow Swiggy, right? Always, most of them will be a foodie. So what they will do, they'll pick up a food, and they'll book it, and the person who's going to deliver us will come and give us where we are located, right? So we have to share our location. So the location and where they are coming, everything will be posted in timely manner with the help of that app. That app is one such example which utilizes geographic information system and remote sensing as an integration that will help us in providing the data that are happening physically. So this is where it is used. So in the world of geospatial science, remote sensing is also known as the Earth observation, where the sensors from the high are observed above its surface. Okay, so the sensors are like simple cameras, except that they do not only use the visible light but also other bands of electromagnetic spectrums. They are so high up that can make images of a very large area. Nowadays, we use the remote sensing mainly done from space using satellites. This has been quoted from the author Bata at the year of 2008. So this is the example of the remote sensing concept which I was trying to say you right now, and the platforms which I was picking up that is going to be available at the surface would either be the platform at the ground surface or at the space also. It depends over the availability of the platforms which we will see at the near future. So this is what I have prepared for today's class. I'll show you a small reference video as a glimpse.
We live our lives knowing that many satellites orbit our planet every day, and that they are helping us in several ways. You might be surprised to know that there are almost 4,900 satellites orbiting the Earth. The most obvious questions that come to mind are, why are these satellites in totally different orbits? How does a satellite carry out all of its functions? And what are the components inside them which help them to accomplish all of their allotted tasks? Let's explore the answers to all these questions in detail. It's a well-known fact that a satellite stays in orbit because of the balance between gravitational pull and centrifugal force. The angular velocity of the satellite is decided by the force balance equation that balances the gravitational and centrifugal forces. When the satellite is deployed, it is given sufficient speed to balance these two forces. A satellite near to Earth requires more speed to resist the gravitational pull than the ones located further from the Earth. Due to the negligible resistance in space, satellites never lose speed. This means satellites will continue their circular motion around the Earth without any external energy source. Satellites are placed either in low Earth orbit, medium Earth orbit,
So this is what I was trying to
or
say. The satellites
geosynchronous
will
Earth
be
orbit.
available only at the
These
orbit.
three orbits are illustrated here. We will
And
get
the
into more
examples which I have
details of them
quoted
later.
in the geo
There is an
Earth
interesting
orbit
region in
is the
space called
satellites
the
that are
Van Allen
available for
belt, a
GIS.
region full of highly energetic charged particles, which could seriously damage the electronics section of a satellite. Generally, it is preferred not to park satellites in the Van Allen belt. The decision on what orbit is to be chosen for placing the satellite depends on the application and purpose of the satellite. If the satellite is built for Earth observation, weather forecasting, geographic area surveying, satellite phone calls, etc., then orbits closer to the Earth are chosen. LEO is the closest to the Earth at an altitude of between 160 and 2,000 kilometers, and its orbital period is approximately 1.5 hours. But these types of satellite cover less area of the Earth, so many satellites are required to obtain global coverage. That's why, in the case of broadcasting, a high orbit such as GEO is chosen. Satellites in geosynchronous orbit are at a height of 35,786 kilometers and rotate at the same angular speed as the Earth. It means the satellite takes exactly 23 hours, 56 minutes, and 4 seconds to complete one rotation. Within the geosynchronous orbit, there is a special category of orbit called geostationary orbit, which is concentric to the equator of the Earth. These satellites remain stationary with respect to the Earth. Due to this, geostationary satellites are the ideal choice for television broadcasting since it means you do not have to adjust the angle of your satellite dish again and again. This is the reason why the geostationary belt is so crowded with satellites, and it is managed by an international organization called ITU. Geosynchronous orbits are occupied by a few navigation satellites also. Geosatellites can cover 1/3 of the Earth's.
Okay, so this is what I have prepared. As you guys can see, the geostationary orbit is the one where the satellites revolve around so that it could help us to collect the data on navigation purposes. I have quoted you some example, that's Swiggy, right? This is where the satellite helps us to collect the data in order to activate ourselves on the data that are available readily from the navigation purpose. And also the low Earth orbits are the one which covers the satellites which are available over there only to sense the Earth or information. This is what the satellites do, yeah, and this is how the remote sensing gets integrated with geo information system. So this is what I have prepared. See you at the next class. Thank you.